Well, hey there, folks. It's Justin from CartoonSmart.com, and we're going to talk about swipe lines today. Somebody on the forums was asking about how to do kind of like Fruit Ninja style swipe lines, and I'll do one better. We'll do two different types of swipe lines here. The first one we're going to take a look at is it's sprite based, or basically just an animation of whatever you want to occur when somebody swipes. So let's take a look. So I'll do something like this, so kind of like a sword swiping type thing, and obviously it's just basically rotating in the direction that we are swiping. What you might be looking for is something like an S shape, and that's the second type of swiping that we'll take a look at. So you'll notice, if I do kind of like a little swirl in here, or like an S type thing, it obviously the animation doesn't kind of bend with the with that shape. But what we'll do is we'll tackle this first one, and then we'll look at that secondary type of swipe, which could be useful. All right, so let's go over here and let's make it's a new iOS project. This is going to be a SpriteKit game. Just click on next, and we'll call this sprite-based swipe lines. Okay, and just throw it right on the desktop over there. And let me actually step you guys over here to Adobe Animate real fast. I'm just going to show you all the just the animation for this. It's really super simple. It's basically just kind of a white stroke with a blue filter around it. So you can see there's just the symbol of it. You got the actually, that might be out of view. You got the glow over here, so it's just blue glow. But it sure looks nice when it's played pretty quick. And that is what I exported out. And I'm going to drop those frames over here into Xcode. All right, and there they are. I'm going to be a little lazy here. I'm not going to make any sort of texture atlas or anything. I'm just going to drop them all right into the asset catalogs. So you can just take them all like this and plop them all in there. By the way, if I did have @2x.png is the file extension in here, I could drop them all in like this and they would all fit into the 2x slots. But for this project, it's all fine if we just use the 1x ones. We will make them zoom up a little bit depending on where you swipe at. All right, so go over here to your actions.sks file. You can go ahead and delete out the one that comes included with the template project. Click the plus sign down there and just write a new action in here named just swipe. That's all we gotta do. And then come over here to this tab, filter it out. You can look for animate. It's an easy way to find this. Just drop this in here. And you can see it just defaults to 1 second. That's it's okay. Let's go. It's a little long actually. Let's go over here to 0.5. Although we can change the time with our code anyway. And then back over here on this tab, you'll see all the images that you just imported. I'm going to select all of them. Okay, and then I'm just going to drag them into here. Okay, so you can see 1 through 11. And we've actually set up now our animation for the swipe. So save the actions.sks file, jump over here to the gamescene.swift file, and let's get rid of all the garbage. Okay, so let's see, let's get rid of touchdown, let's get rid of that, and that. Let's get rid of all this. We do want our, we don't really need the touches canceled, but otherwise, yeah, so pretty much just get to this point right here where we'll make use of our touchdown and our touch up. We'll go ahead and leave touch moved in there though, even though we're not going to use it for this particular part of the lesson. All right, so let's go declare some variables. We're going to come over here outside of all the functions, and first one's just going to be the sprite. This is going to be what appears when we swipe. And let's make another variable, var .1. This is going to be a CG point type variable, and just for right now, set it to CG point.0. And a CG point can hold 2 points, an X and a Y. And we'll create another point. The first one we're going to use when we touch down, and the second one we're going to use when we touch up. And in fact, that's actually the point we're at right now. Let's go and Let's go over here to our touchdown statements, and we're just going to say that point 1 is going to equal the POS or position. And again, these are just the functions that came with the template. So the touchdown function over here takes in the parameter of or CG point parameter, POS, position, and we'll hold on to that. So let's go ahead and copy that. Put this over here, point 2. And when we touch up, what we're going to do is actually go about adding that sprite to the scene. And what better function name than, how about just add sprite? Although sprite soda sounds kind of good right now. Okay, function, add sprite. If only I could make that machine. Okay, so we're going to say the sprite is going to equal sk sprite node. This is going to be image named. And go ahead and just put in here the first image that's going to come included with the source files or the project files, which is just going to be swipe. Actually, there's an S in there. Swipe lines 0. There's 3 zeros in there. 001. Okay, so it's basically just this right here. Might be better to just copy that, paste that in there, be sure we got it, and we can go ahead and add the child to the scene at this point. But we're going to do quite a bit of adjustment in here. One of the things we'll do is we'll actually set the position to 0.1. Okay, so by default it's going to be right there. And then let's go and try to make sure that that action that we created, the animate with textures action, actually works or exists. So we're going to say if let swipe action, sk action equals sk action, and then we're going to put in here named. And then you just repeat back the action name that you gave it, which was swipe. And here's where you can determine or you can set the duration code-wise, okay? And I'm going to keep it at 0.5. But yeah, it can be anything you want in the code. Doesn't matter what you put over here, right? And again, here's that name, swipe. So once you get that, then come right here and just write the sprite.run. And then we're going to put in here swipe action, okay? And actually, you know what? At this point, you could, if you just want to make sure that it's working, good idea to make sure it's working at this point. Let's see. The iPhone 8 Plus is warming up. Guess I could have picked on the 10, but we'll go with the 8. For some reason, it's the last one I chose. All right. And you can see, yep, it's just going to leave this little lingering trail of the final image in there. That's something that looks kind of cool, actually. Yeah, some of the times when I'm doing something like this, I'll put in one blank frame at the end, and I kind of forgot to with this, but it doesn't really matter because we're going to include in here at the end of this function a sequence of actions, and let's go ahead and write those. This is going to be dot wait for duration 0.5. So basically we're just going to wait and then remove it. Okay, so sk action is going to equal sk action dot remove from parent, and then the sequence here is going to be, or actually we're just going to go ahead and run this. We're going to say the sprite, and then we're going to create this action sequence within this run function. So we're just going to put in our sk action dot sequence, and then what it wants is an array of the SK actions you want to run. So you just put in here wait and comma separate them, remove. We could put more in here if we wanted, if we had more, but that's actually all we got. So we're just going to put wait, remove, and at that point when we run again, we should no longer see the that last frame lingering in there, and there you can see it's gone. Okay, so the problem is we need to rotate this guy, obviously. And it would be really nice, too, if we could kind of adjust the size based on how much we were swiping. All right, so let's do that within here. And first things first, so let's make this guy rotate. So we're going to say let v1, so it's short for vector. And vectors are a lot like CG points in terms of their setup. fact, I think you've got a CG vector dot zero if you want it. And then we got dx and dy. The important thing here is that we just put in here 0 and 1, okay, for this first vector, and then for vector 2 here, it's going to be CG vector, and here's where we get into some interesting math. Dx, we're going to say 0.2, okay, so that's where we lift it up from, all right, that second point, minus the sprite dot position dot x, and then dy is going to be 0.2 dot y minus the sprite dot position dot y. Okay. Now, here's the math that I don't really get. But if you were to Google something like get the rotation of 2 vector points or whatever, something like that, 2 locations, you're going to come across this same function over and over again. And if you really want to find out more about it, feel free. Something to do with tangents, things I wasn't paying attention to in high school. v1.dy. Okay, I just want to give you the angle. So put in here the sprite dot z rotation, and it gives it to you in radians, which is fine for z rotation because that's what it's expecting it to come to you as, or for you to provide it with. And yeah, there you go. Euler rotation about the z-axis in radians. And now, if we were to run this, if I put in all those things that I'm looking at from my notes correctly, yep, that looks right. Go this way with it. Goes down that way. And you can see the only kind of issue really now is just that, if you start over here and you go kind of let go all the way down here, you'd probably expect a bigger animation, right? So that is where we're at. And let's put a little note here. We'll say set the rotation. And put in here, optionally adjust the size. Okay, so to do that, let's figure out what the greater difference here is. So if you were to swipe from left to right over here, you're making basically the difference between your x location of your starting point and your ending point is going to be greater than the y difference, right? Because you're basically going on a straight line. Okay. But if you were to do the opposite over here, obviously your x location of them is about the same. Okay, oh, there we go. Didn't know that would happen. So that's what we're going to be looking at, and we're going to hold on to a variable here. We're going to create a new variable that's going to hold on to the greater of those two values. Okay, so diff to use or difference to use. That's what that's what that means. And then the next one, we're not going to change this, so it's going to be a let type variable. Okay, diff on y, cg float, and this is going to be the absolute value. Okay, so it's not going to be a negative value of 0.1.y minus 0.2.y, and let's just do the same thing for the x and x. All right. And then what we want to know is which of the two of those was actually bigger. And I think in most cases it's usually the y. So we'll say diff on so basically if diff on y is greater than diff on x, then the difference to use is going to be diff on y, and then else this is going to be the diff on x. Okay, then what we're going to do is do a little bit of math on that value. And actually, first, I'd rather print this out to show you guys what it equals. So now every time we swipe, we're going to see what the diff to use is. So let's go left to right here. 405 in that case. That seems like I went about 405. 137. Let's go all the way down here. 852. So what we really want is some smaller numbers out of this. So let's do something like this. Let's say divided by 200, okay? And, you know, there's a couple ways we could go about it. We could make the X scale and the Y scale equal to, you know, exactly whatever this is. Obviously, we'd want to make sure that it didn't get too low at any point. So you can see, you know, 4. So basically, if I go like kind of as far down as possible, yeah, that's probably a bit big. That's getting into some better numbers. I'd probably say divide it a little bit more. But this is where you'll probably want to make some changes based on, you know, your exact animation. But so here's what this would look like. We'd say the sprite, and actually, you know, I need to put this over here. So diff to use actually has that value with the division in there, not just printed out. And so we'll say the sprite.xscale equals .xscale plus diff to use. You could use that. Or you could just make it equal to that. Okay. I think the main thing you want to do here is make sure that the X scale and the Y scale always stay the same. So what you can just do is, you know, Y scale equals the X scale. And then if you want to throw in here some, you know, some ways of making sure it doesn't get too big, you could say if the sprite.x scale is greater than maybe 3, then you just kind of cap it at 3. So you'd say it's going to equal 3. And again, I think it's a little bit easier if you always make the Y scale just equal to whatever the X scale is. That way, if you start monkeying around with the numbers or whatever, you don't have to go change it in 2 places. So let's see what we got. This is actually a little bit different than my code in the demo. Yep, it looks a little bit different. It's a little bit bigger. Yeah, but I think that looks pretty good. I didn't plan on talking 17 minutes about this though, so that means if you were here to hear about the S-shaped lines that we create at runtime, well, I guess that's going to be in the next video in this very short 2-part series. But there you go. You've got an animation-based or sprite-based swipe line.